Good morning, all. Can you hear me? I think total 55 students joined. So we will start our lecture. My voice is clear?
Yes, sir.
Yes, sir.
So today we are going to learn the melting furnaces. Right? So at the start, we have seen the different terms in the casting, and we are studying the terms one by one. Okay. So first, what we have learned? We have learned the pattern. All detail about the pattern, what is pattern, how to make the pattern, what are the materials used for pattern, what are the allowances used in the pattern that we are saying. Right. Then we have seen the molding. How to prepare that mold means we need sand. So we have seen the detail about molding sand. What is the molding sand? Different types of molding sand, ingredients. That part we have seen. Right. Now with the help of pattern, we have prepared the molding sand. With the help of pattern and molding sand, we have prepared the mold. We have prepared the cavity. Now in this cavity, we want to pour the molten metal. Whatever the metal we have, we heat it, we make it uh, as a molten metal, and then we pour it into the cavity or mold, and we get the parameter. So how to get this molten metal? To get this molten metal, we require the furnaces. That is melting furnaces we require. Right. Now in the casting, we can manufacture, we can produce any material. Let it be cast iron, steel, aluminum, copper, nickel. Here you can see the number of materials which we can manufacture. These are the some of the material. We can manufacture many material. Okay. Now every material have some melting temperature, melting point or melting temperature, right? Now, if suppose we take the example of the gray cast iron. Here, the melting temperature of gray cast iron is 1370 degrees Celsius. Right. But if we heat this gray cast iron up to this temperature, that is 1370 degrees Celsius, it is not sufficient. Why? Because at that temperature, it only melts. If suppose we heat the gray cast iron up to this temperature and we try to pour into the mold, whatever the mold we have prepared, we try to pour that molten metal. So it will not get flow properly and it will not feel the gravity properly. Okay, so that is the disadvantage. If you heat only up to the melting temperature, then how to overcome this problem? So by heating up to the pouring temperature. Right. So what is melting difference between melting temperature and pouring temperature? At the melting temperature, it just melt. Okay, but it is difficult to flow. If you want to increase the flowability of that molten metal, then we need to increase up to the pouring temperature. Means what? We can easily pour that molten metal into the cavity, and it can fill that cavity. It can flow into the cavity easily. That's why we need to heat up to the pouring temperature. Right. You can see the different example as we have seen the gray cast iron. Its melting temperature is 1370 degrees Celsius, but we need to heat 200 degrees Celsius more. Right. Here you can see 1510 degrees Celsius, 1590 degrees Celsius. Then same cast iron. Its melting temperature is 1480 degrees Celsius, but we need to heat up to 1600 or 1700 degrees Celsius, depending on which type of steel it is. Same in the case of cast iron, nickel, aluminum, zinc. lead, tin, okay, different types, copper alloy, nickel alloy, gunmetal. So melting temperature is different and here pouring temperature is different. We need to heat more. We need to heat up to pouring temperature. Now, how to get this much amount of heat? The highest temperature you can see here in the casting. How to get this temperature? 1600 or 1700 degrees Celsius. So we get that heat, that much amount of heat from the melting furnaces which we use in the casting. Okay. So this is the one important concept, that is we need to heat our metal, whatever the metal we are using, up to the pouring temperature in order to get the good flowability and in order to fill the all part of cavity. Right. Next, the furnaces which we use for getting that much amount of heat. So these are the furnaces which we use for melting and in the casting process. That is crucible furnace, cupola furnace, electrical arc furnace, induction furnace, resistance furnace, then rotary furnace, and reverber furnace. These are the furnaces. In this, some of the furnaces require electricity, electric current, and some of does not require this electricity. Just they require the fuel like coal, oil, gases, air to generate the heat. So let's see which requires electricity, which. So one by one we will study these types of furnaces. So the first type of furnace is the crucible furnace. Okay. Now, what is crucible? So crucible means what? We need to store. Let's suppose this is a pot in which we are providing the heat, right? And here is our scrap suppose, and due to heating it gets converted into the molten metal. Here it is the molten. Here is the molten metal. Now, whatever this device or pot we are using for holding this molten metal, that should sustain this molten temperature of molten metal, right? For that, this temperature of the melting temperature of this device or pot or crucible should be high as compared to the material which we are heating. So that's why we make this crucible furnace or crucibles. So with the help of, so there are silicon carbide plus clay plus resin. So with the help of this, we prepare this crucible and then we go for heating to get the good steam. And once you prepare the crucible, whatever the scrap is there which we want to melt, that will pour into the crucible. Right. Now here, with the help of fuel, here we use the fuel. What type of fuel we use here? Coke, that is coal plus oil plus gas. Such type of fuel we use, and we supply the gas or air to generate the heat with the help of this fuel. Now what happens when it generates the heat? Okay, so that heat will pass through this crucible and it will reach to the whatever the scrap is there, and that scrap will start to melt. Okay, and in this way we will get the molten metal from the crucible. It is a simple type of furnace. With the help of air gas, we blow this whatever the fuel is burning, and with the help of that we get the more heat, and with the help of it, whatever the scrap is there inside this crucible, that will get melt. So here you can see the crucible furnace, one type of crucible furnace. Here you can see the opening. Okay, whatever the gases are generated, that will get escape from this opening, and inside the crucible we have the our molten metal or material. Right. So this is the first type of furnace, that is crucible. So it is very simple. Now, what are the advantages of this Once another type is, once the molten metal is prepared up to be heat up to the pouring temperature, then what we lift this, okay, with the help of some lifting machine. So you can see here, if you are able to see here, what we do, we just tilt it like this, and by tilting it we get the molten metal out from this. Whatever the molten metal is prepared, we get out of this, and that we collect into the ladle, and with the help of ladle we pour into the molten metal. Okay. So it's if we compare the advantages, so the advantage of this are, its maintenance cost is sorry, installation cost is less. Okay. Then its initial cost is also less. Whatever the setup cost is there, so its initial cost is also less compared to the other. And this furnace is used for non-ferrous, okay, non-ferrous alloy. Generally, this furnace is used for the non-ferrous alloy. Okay, so this is about the pressure furnace. It is very simple furnace. Next type of furnace, which is very old type of furnace, that is cupola furnace. Okay, so it is the oldest and simplest furnace. So cupola, if you see the name, this cupola is derived from the Latin word. Okay, that is the cupola. What is cupola means? It means barrel. Now in the diagram, you can see the barrel shape. Okay, this is the barrel shape. That's why it is called a cupola. Okay. So it is similar like a blast furnace, and generally it is used to manufacture product cast iron and steel. When the material is cast iron and steel, generally we go for the cupola furnace. Right. Now here you can see the arrangement of this cupola furnace. Okay. So at the bottom there is a tap hole. Here you can see the tapping spout, means this tapping. What is tapping? So tapping is the opening for molten metal. So you will come across this word tapping in next furnaces also. Okay, so this tapping spout or tapping is used to get the molten metal. What are the molten metal we have prepared? So that we'll get from the tapping from here. Okay, like this, we'll get the molten metal, and we will collect into the ladle. Okay. There is also slag removal. Okay, here you can see the slag spout. Okay, so here, if you get the molten metal here, I will explain where we get the molten metal. Just first of all, we will see the construction. So now we know we have the scrap, okay, or ores or pig iron. Suppose we have the pig iron. Now we insert that pig iron or scrap into this cupola furnace. Now it may contains the unwanted parts, that is called slag. Right? When we melt our molten metal scrap, what happens? Whatever the slag is there, let's suppose this is the molten metal. So molten metal will be at the bottom and slag will be at the top. Why slag will be at the top? Because its density is less compared to the molten metal. So at the top we get the slag. So first of all, what we do, by opening the slag spout, we get the slag out first. And once we get the once we remove the slag, then we go for opening the tapping and we remove the molten metal. Okay. Now coming to this part, wind box and these two airs. So this is used to supply the air or gases. Now here I have the video, there you can understand how this cupola furnace works. So here we have the fuel, that is coal. Right. Now we first of all burn this coal, and to get the more heat, what we do, with the help of this wind box and fuel, we supply the air and different gases so that we can generate the more heat. Okay. So this is the function of this wind box and fuel. Then here what we have, charging door, and this is charging floor. So height of this is nearly about 10 meter, height of this cupola furnace. Okay, that's why we require the floor. So by standing on the floor, suppose the worker is standing on this floor. By standing on this floor, we charge the floor. What is charging? Charging means whatever the scrap we have, whatever the scrap or pig iron or ores we have, that we pour into the furnace from this opening. That is from charging door. Okay. Now this is a stack. This above the charging door is a stack. What is the stack function? So it collects. So what are the gases are generated that will be collected in this stack, and at the top we have the spark arrestor. Means what? In the cupola furnace there are some gases are generated which are harmful. Okay, some extra particles. So that particles are arrested, means that are collected in the spark arrestor. Okay, and other gases are released. And what are the harmful particles are there? Big particles are there that are collected in the spark arrestor. Okay? And here you can see the bottom door. So here, and this is the bottom prop. So this is used now when we want to close this cupola furnace, right? When this coal is burned, so it creates some ash. Okay, and when we want to clean that cupola furnace, we remove this. We remove this bottom prop, and whatever the ash is generated, whatever the other particles are there, that will get removed from this. Okay. So these are the different parts of this cupola furnace, and now we will see one video how this cupola furnace works. There you can understand this. Can you see this cupola furnace?
Yes, sir.
Okay. Now this is the cupola furnace. Okay, as I told you, the height of is about 10 meter. Okay. Now here is the spark arrestor where we collect the particles, harmful particles. Here you can see. Then there is a floor. Okay, so this is a floor from which we charge this furnace. Okay, so these are the charging methods like pig iron. Okay? And here you can see, so the machine blower from which we pass the air so that we can get the more flame of this fuel. Right. Now we will see the inside part. So this is the floor from which we pour our charge. So this is the door, charging door, as I told you. So this is the coke, limestone, metal. So this depends on what composition we want. Depending on that, we charge this furnace. Okay. This is charging door. We open the charging door whenever we want to charge this cupola furnace. So what are the compositions required? According to that, we supply this. Now it is charging the furnace. Once we charge, we close the door. Now here you can see. So here is our tapping, and here is our ladle. From the tapping, we get the molten metal. And here you can see the coal, which is used as a fuel. And as we blow the air, so the coal will generate more flame, more heat, and that heat is used to melt this scrap or pig iron. Okay, so as the firing action starts, it will move. So it will make this. Okay. Now, what is the drawback in this? Okay. So here our fuel and the material is coming in directly contact. as you can see here. Okay. Now once it is heated, and we get the molten metal from this tank. Okay. So this is how it works.
Sir, how is that a drawback if the film and molten metal are
Yes.
in contact? How is that a drawback?
So what happens as we are using fuel as a coal? Okay, so coal contains carbon. Okay, so it will disturb our composition. So that carbon will be as a part of our molten metal. Okay, so that is the main drawback, because coal or fuel have different types of you can say gases or different types of material. So as your material and fuel is coming in direct contact, so that will get mixed with your molten metal, right? And as it is this mix, your composition will get disturbed. Whatever the composition earlier you are deciding, that will get disturbed. Carbon percentage will be increased. Okay, and that changes the properties of casting. That is the main drawback of this blast furnace. Understood? Whatever. So this is the cupola furnace. Now here you can see there are different zones. Uh, at the start we pour this whatever the charge is there, scrap is there, then it is preheated in this zone. Okay, as heat is passing later in this stage, that's why it is a preheating zone. Okay, then it is coming in contact with the whatever the fuel we are using, so that's why it will get melt. So that's why it is called melting zone. And as we have discussed, we need a cooling temperature that we get in the superheating zone. Okay, so this is the superheating zone, and in the after superheating zone, it will get melt and it will get collected into the well, and from that well, from with the help of tapping, we get this molten metal. Okay, so this is the working of our cupola furnace. So the advantages of this is it is simple to operate. Okay, once we have constructed this cupola furnace, what we need to just charge the cupola furnace, and at the bottom we will get the molten metal. Okay? And then the most advantages, most use of this cupola furnace is we get the very high melting rate. High melting rate. Okay, so the range is 1 to, depending on the size of the cupola furnace, 1 to 35 tons per hour material we can melt in this. Okay, and more it can be operated continuously for the months, 2 months. You can operate this cupola furnace continuously. Earlier they were using the cupola furnace only. So industries were used to run this cupola furnace for 6 months. Right? So it's a long running. It has the long running capacity. Plus, as you can see here, no electricity is required. Okay, no electricity is required in this. So these are some advantages, and disadvantages, as I told you, here temperature control. Temperature control is difficult in this. Okay, once we fire, okay, the molten metal will get melt, but the temperature control is difficult in this. And second is that, as I told you, whatever the fuel we are using, that is in contact, directly comes in contact with the charging material or the scrap. That's why whatever the materials are there in the fuel, that will get entrapped or get as a part of a scrap. So that will change our composition and that will change our properties. So these are the drawbacks. Plus, as we are using coal, that will generate the gases and that will get escaped to the environment. So that is why it creates environmental pollution. So these are some disadvantages. Right? So we are learned the crucible furnace and then the cupola furnace. Now the electric arc furnace.
Excuse me, sir. What if we increase the temperature beyond the pouring temperature?
Beyond the
Pouring
beyond the pouring
temperature.
temperature, it will start to evaporate, because what happens, uh, if you see the composition of cast iron, this it contains cast iron, or if you want to form the alloy, and some alloy has some less melting temperature. So if you pour sorry if you increase the temperature beyond pouring temperature, it may start to evaporate. Okay, so that is the problem. And in some cases, due to the increase in pressure, the furnace may blast. Okay, whatever the crucible we are, so here you can see the fire bricks. Okay, it may blast when we pour the molten metal, when we increase the pouring temperature. Okay, so it may hit the fire bricks. Okay, it may damage to this. Okay, so that things can happen when we increase the temperature more. Then the
Okay.
next is the electric arc furnace. In electric arc furnace, as the name, we use the electricity in this. Here you can see, here is the roof, which we can remove for charging this. Now, whatever the scrap or ore we have, we collect here, we charge here, we put here, right? Now, these are the walls of our furnace. We can see there's a refractory lining. So again, either these are made with the fire bricks or the crucibles, right? Now these are the electrodes, graphite electrodes. You can see here, these are the graphite electrodes, and to the graphite electrodes we supply the electricity. Now, once we supply the electricity, what happens? This graphite electrode will generate the sparks. Right? Now, due to the generation of this spark, it creates the heat. And due to this heat, large amount of heat, whatever the scrap ore we have here, that will get melt. Now, as we have discussed, when it get melts, whatever the molten metal is there, that will get collected into at the bottom, and whatever the slag is there, here you can see the slag, so that will get collected at the top because its density is less. Okay, now suppose the metal is melted, then what we do, we tilt in this direction first. Why? To remove the slag. So this is a slag removed from the surface to this door. Okay, we open this door and we tilt this, and first of all we remove the slag. Once we remove, then again we tilt this electric furnace in this direction. Whatever the molten metal is there, that we remove from this direction. Okay? That is, we get the purified steel. So this is the working of electric furnace. Actual diagram you can see, actual setup you can see here. So once we tilt this, whatever the purified steel is there, purified steel is what? After removing the slag, we get this. Again, we'll see this with the help of. So this was the cupola furnace. Okay, this is our electric arc furnace. Here you can see the electrodes, graphite electrodes, and here is our scrap, right? And these are the power supply given to the electrodes. This is the crucible. Here you can see the walls. What is the purpose of these walls? Because this should not get fused with the molten metal, and it should sustain that high temperature. That's why we make with the walls, refractory lining, we call it as. This we first of all we insert the scrap by removing the roof. So that difference we will see. Then we close this roof, and that contains graphite electrodes. We supply the we give the electric supply to this electrode, and what happens? It generates the sparks. As it generates the sparks, it will generate the heat, and that heat is used to heat our scrap. As it is heated, it gets converted into the molten metal. Once it is get melted, and then we remove. Okay, so that is not here. Okay. So this is the working of this electric arc furnace. With the help of electricity, graphite electrode, we generate the heat. As we generate the heat, it get melt.
Sir,
Yes.
how we maintain temperature of electric arc furnace?
Yes. By maintaining the electric supply. So this is the main advantages of this compared to the cupola furnace, that with the help of electric supply, we can control the temperature. Here advantage is what? We can control the temperature. And here this as it is generated sparks, okay, whatever the composition is there, that will be maintained. Okay, that will not come in contact with the this graphite electrodes. Okay, only the spark is in contact, right? Then, as I said, the temperature control is the main advantages. And here, compared to the cupola furnace, the time required for getting the molten metal is short compared to the that our cupola furnace. Okay. And what is the disadvantages? Electricity cost is high. So as it is required the electricity, in this electricity cost is required high, and plus here installation cost is also high. Installation cost is also high. So these are the disadvantages of this electric arc furnace, electricity and installation. Advantages is that we can control the temperature properly here, and the required time for getting the molten metal is also short. As it required, as it generates more heat with the help of this arc. Okay. So we have seen crucible furnace, cupola furnace. In the crucible furnace also we don't require the electricity. In the cupola furnace also we don't require the electricity. And then we have seen the electric arc furnace. Now the next is induction arc furnace. So it works on electromagnetic principle. Okay. So here you can see the setup. Here you can see the actual diagram. Okay. So these are the crucibles, and here we pour the charging material, and these are the coils. Okay. These are the copper induction coils. So what happens? We give the supply to the copper induction coils. Okay, and these are surrounded to the our crucible. Here you can see the diagram. Okay, these are the surround to the crucible. In this, the change is the crucible thickness. As compared to the cupola furnace or electric arc furnace, here thickness of crucible is less compared to other. And here we have the charging material. Now what happens? These are electrically conductive materials. So the disadvantage or demerits you can say here, only electrically conductive materials we can use for the induction arc furnace. Okay. Now we put the pores scrap here, okay, which is electrically conductive. Now once we supply the electricity to these copper coils, these are the surrounded. So what happens? Secondary currents will get developed into this, and as the electromagnetic force is also generated, so as the secondary current is developed into this scrap, okay, so that will generate heat into this, into the materials, whatever the scrap material is there, so that will generate the heat into this secondary current, and as it is generates the heat, so it will get melt, and that molten metal we remove here. You can see the electric. So So this is the working of this electric furnace, induction furnace. We use the copper coils. To the copper coils, we supply the high frequency current. So as we supply the high frequency currents, the secondary current will be induced into the metal charge. Okay, and this metal charge will offer resistance because these are the separate parts, and this resistance will generate the heat. Whatever the resistance is developed in this scrap, that will generate the heat, and as it generates the heat, that heat is used to melt this. We can take the example of water heater. Okay, so coils, due to the coils, what happens? It generates the heat, and that heat is used to heat the water. Same principle is applied here. Okay, to heat the molten metal. Okay, so that is the working of this. Here, what are the advantages? First of all, crucible thickness. So as the crucible thickness is less, the cost required for this is, the crucible cost is less. It is less. That is the main. Then what we can say, disadvantage is what? The main disadvantage is only electrical conductive materials we can use in this, because that should generate the secondary current in the induction furnace. Okay. Again, here no contact between the fuel and fuel means electric, this copper coils and our molten metal. Okay, there is no contact, so there is no change in composition. So these are the some advantages of this induction. Limitations, as disadvantages as I discussed, electrically conductive material required. Then cost is also high, and the electricity required. So electricity cost is also high. Okay, and here only small quantity of material we can melt. Okay, for the large quantity we need to either use the electric arc furnace or cupola furnace. Only small quantity of material we can heat in this furnace. Okay, so that is one more disadvantage of this induction arc furnace. Right. Coming to the next, resistance furnace, it is similar to the electric arc furnace. So there we generate the arc, right? Here you can just see the setup. These are the crucibles, means firewalls. Okay, and so this is the wire. Here we have the scrap. Okay, now what happens? We supply the electricity, power supply. We give the power supply to these wires. Okay, and this is called resisting element. As we are supplying high electric current to this resisting elements, what happens? So it will generate the heat. As it is resisting to our current, that will generate the heat. And whatever the heat is generated due to this resisting element, so that heat is used to melt this workpiece. Workpiece means whatever the scrap is there. So that scrap is heated with the help of this heat, whichever is generated due to the resisting element. So that is the principle of the that is the working principle of this. Okay. Here also we can control the temperature properly with the help of power supply. Okay. And once it is heated, we can remove the molten metal. Here we can see the passage for the molten metal. This application is used for steel and non-ferrous alloys. Okay, so this is the application of this. Understood? This is the working of this resistance furnace. Only we use the resisting element, and as we supply power or electricity to this resisting element, it generates the heat, and that heat is used to melt our workpiece or scrap, and that once it is melt, we get the molten metal from this. Okay, so this is the working of resistance furnace. Okay. Coming to the next furnace. Next furnace is the rotary furnace. Here you can see the actual actual rotary furnace, and here is the schematic diagram. So this generally this is made up of steel. The outer surface of this rotary furnace is made up of steel. Now here the advantage of this rotary furnace is as it is rotating. Okay, so whatever the composition we are using, suppose cast iron, some we are adding some alloy, so we get the good mixing of these alloys with the help of rotary furnace, because it is rotating, and as it is rotating it will mix the all alloy whichever we are using properly. So that is the main advantages of this rotary furnace, right? Now this outer surface is made of steel. Here you can see, so a part is burner. Here you can see the burner. So with the help of blower, okay, here we charge, here we have the our fuel. In this location we have the fuel, and with the help of this burner we burn this and we generate the flame and heat, right? And inside this we have the scrap. Inside this shell, that is rotary shell. You can see the B part. Here you can see the B part, that is the rotary shell. Inside the rotary shell we have the scrap. Now these flames, these hot gases will burn this will heat this scrap, and it will get melted. Whatever the scrap is there, that will get melted, and it is rotating. Due to the rotating action, what happens? So whatever the composition is there, that will get properly mixed. Right? Now the C part you can see. So this is a crucible. It is throughout these crucible walls. Okay. So after the steel, there is a crucible walls to sustain that heat. Okay. That is the, this is the rotary refractory lining, that is crucible walls. Then D part is roller. So here you can see the roller. If you are able to see here roller. So these are the rollers which are used to rotate this. We are going to see the video how it works. Okay. So these are the rollers which are used to rotate this rotary furnace. Okay. Then the pouring spot. Here you can see the pouring spot. From this we get the molten metal out. Okay, the molten metal is there. So here, if you see the here, we open this, and once it comes at this position, we get the molten metal. Here you can see the molten metal. Okay. The shape you can see, this its shape is cylindrical. Then what we have, the exhaust stand. So this is the exhaust stand, and this is the exhaust way from which whatever the exhaust gases are there. Okay, here you can see exhaust gases are generated. Okay, exhaust way. So that exhaust gases will be collected through chimney and it is sent out. Okay, so H is the chimney part, and I part is the blow, which is used to blow this heat. Okay. So this is the construction and the working of this cupola furnace. Sorry, rotary furnace. Now we will see the video of this so that you can understand how it actually works. Okay, this is the actual working of this rotary furnace. Can you see this video? Can you see this?
Yes, sir.
So here you can see these are the rollers, and this is our rotary furnace, and here you can see the pouring cup tapping here. From this we get the molten metal. Okay, this is rotating at very low speed, nearly about 1 rpm, 1 rotation per minute. At this low speed it is rotating. Okay, and how it is rotating? With the help of roller. Here are the rollers. Okay, now see, they have opened this tapping, and once it comes at this, they will stop this rotating furnace and will get the molten metal. Okay, here you are getting the molten metal. We will stop our rotary furnace, and we will collect whatever the molten metal we have prepared, that we will collect. Now here you can see the blower from which we generate the flame. Here is our gases, fuels. Okay, with the help of this, we generate the gases. Now here you can see the blower. So by opening or closing of this knob, you can control the temperature. Here you can see the knob. With the help of this knob, we can control the speed of air, okay, which is passing from this, and by this speed of air, we can control the temperature. Here you can see. Okay, here you can see the hot gases which are coming out of these furnaces that will get collected from exhaust gases, exhaust fan or exhaust mounting, and that will collected through chimney and that will pass to the atmosphere. Okay, these are the hot gases are coming out. You can see here. Okay, and from this heat is generated from this location. Now once we get the molten metal, we start this rotating. This is the molten metal. Okay. Then we pass to where we require, and there we pass. Or if you want to mix some alloys, then we can mix in this. Okay, so this is how it works. Rotary furnace. Okay, biggest advantages of this rotary furnace is, as I told you, mixing of alloy is the biggest advantage of this. Right. Now the next and the last is reverberatory furnace. You might have learned in the chemistry, okay, in 12th or in the first year. Okay, so this is the reverberatory furnace. How it works? So you can see these actual diagrams of this reverberatory furnaces. So here, this is the roof of this reverberatory furnace. Okay, and this is the hearth. Hearth means what? The portion where we collect the molten metal, right? And this is the out passage for these gases. Here we generate the heat with the help of fuels. Suppose here there are fuels. With the help of some gases, air, we generate the heat, and that heat will pass through this. Okay. Now, how it works in this reverberatory furnace? First of all, it will heat the roof. First of all, it will heat the roof, and this roof will refract the heat. Okay, so the refractory heat from the roof will be used to heat the ore, whatever the ore or scrap is there, that is heated with the help of heat which is refracted from the roof. And then after this, the gases are passed. If you see, this is the long rectangular structure of, okay, with the removable. This roof is removable. By removing, we can add this ore, right? And here fuel is used as oil, coal, this type of fuel we are using. With the help of this fuel, we generates the heat. And this flame will pass. First of all, it will heat the roof, and that heated roof will refract the heat, and that heat is used to melt the molten metal. This is how we generate the molten metal. And once it is get melted, and that we will remove. So here these are the passages. Okay, some mixture here. And from this passage, by tilting it, we get the molten metal. So this is a working of reverberatory. Here applications are we use for the cast iron. Okay, then we go for using non-ferrous alloy. Non-ferrous alloy. Okay. These are the furnaces. So today we have learned why we need the furnaces to melt the or scrap molten or ore pig iron. So these are the furnaces we have seen. Okay. First of all, crucible furnace was crucible and cupola furnace, which don't require the electricity. In this, with the help of coal, okay, some oil, we generate the heat, and with the help of that heat, we melt our material. Then we have seen the electric arc furnace, induction arc furnace, resistance furnace. With the help of electricity, we generate the heat, and that heat is used to melt our material. Okay, get the molten metal. Once we get the molten metal, that is been taken into the ladle, and with the help of that, we pour into the mold, and we get the cast. Then to get the proper mixing, to get the proper composition, we use the rotary furnace. We have seen how rotary furnaces work. Okay, so there is a shell, steel shell, into which we pour our scrap, and that is getting rotated, and from that we supply the flames with the help of blower, and that heat will cause our scrap to melt, and that molten metal will take. And the last one is the reverberator furnace. Reverberator furnace, how it works? We supply the flame. That flame will heat the roof, and that heated roof will reflect the heat, and that heat is used to heat our scrap. Okay? And that will get melted. So this is how all the workings of furnaces we have seen. Okay. So we have completed the melting furnace. Tomorrow we'll start with the gating system.
Excuse me, sir.
Yes.
Do we use metal for core making?
No. Generally, only sand we can use. What happens when we use the metal as a core? We in casting we are using the metal only, different types of metals. Okay, so that metal may come in contact with that core, and the surface of core may get fused with the molten metal. That's why we don't go for using metal for core making. And only we use the sand. Core sand only we use for the core making. Right? If you use the metal, that will get fused.